Welcome everybody to my class, and today we will be learning about inequalities. This is the 7th grade curriculum, so this will be our first inequality class. You may recall that in our last classes, we talked about systems and linear equations, very basic ones. So now that you have a basis of algebra, it will be easy to learn about inequalities, which is also a section of algebra. So this is our schedule. First, we're going to review how to solve basic algebra linear equations. This sounds easy, but in our last class, some students had some trouble solving and using inverse operations and that kind of stuff. So it'll be a brief review. And then I'm going to introduce inequalities for those who don't know. And then we're going to be graphing some inequalities. We're going to graph both single variable inequalities and both in two variable inequalities. So can you all see my screen and hear my voice so far? Any questions on the schedule? Yes or no? Okay, no questions. I'll move on. So first, I'm going to go over inverse operations and basic equality. These qualities are essential for solving linear equations. Okay, so here's this is a very simple linear equation, okay? Very simple. Now, you might ask, why do we need to go over equations when we're solving inequalities, right? Inequalities look like this, and equations look like this. They have different signs, and equations have equal signs. Now, the way you solve equations and inequalities is the same. You need to use inverse operations, and you have to, if you do something to one side, then you have to do it to the other. So let me review. When we try to solve these algebraic equations, we try to isolate x and put all the other numerals from it, and then we can get what x equals. So basically, what we just have to do is we have to move this x away from this 2, and then we can get x equals 2, right? Now, how do we get x equals 2? So we move the x to the left-hand side, right? We get x equals 2. Just a one-step linear equation. Now, why is it 2x and not 3x? Why isn't it 2x plus x? And I've gone over this a lot of time, and I just want you guys to review the inverse operations. When you move this x to the other side, what you're really doing is you want to cancel x out on this side and move it to the other side, right? And to do that, you have to subtract x from the right-hand side. And remember, this is an equation. So remember basic equality, you have to subtract x from both sides. What you do to one thing, you have to do to the other. Okay, so let's do a warm-up. Okay, should be very easy. Probably 30 seconds. Okay. 4x equals -5 plus 2x. Okay, I'll give you a few moments to solve this one. Put it in the chat box. Okay? Okay. So we have a few answers. Steven says it is -5/2. Kai says x equals -2.5. And yeah, that's about it. And negative 2.5 is the same as negative 5 over 2. So basically same answers. Let's check. Okay, so first step, move the 2x to the other side. This actually is a two-step process. Okay, once we moved it, 2x equals negative 5. Okay, and then our next step, we have to divide both sides by 2, right? To get x by itself, we don't want 2x. We care about what x equals, not 2x. So we just divide by 2, get rid of the 2. But remember basic equality, we have to do it to both sides. X equals negative 5 over 2 or negative 2.5. Okay, very easy. Now, solving algebraic equations. So here's a tip, and I already mentioned this. Once you know how to solve equations, you should know how to solve algebraic inequalities. There are just a few differences when solving algebraic inequalities, and I'll go over that later. Okay, so we already solved a few simple ones. Let's solve some harder ones. Okay, so 5 times x plus 4 minus 2x equals 3x minus 4 times 2 plus x. Okay, this seems very complicated, but it's really just a bunch of rubbish and just distributive property. Once you unwrap the parentheses, you can combine it and it'll just be something very simple. Okay, I'll give you 1 minute to do this one. If you know distributive property, this should be quite easy. Okay, another warm-up question, and then we'll get on to some practice problems. Okay, and then I'll introduce you to the inequalities. And so what I'm really doing here is I want you to have a good knowledge of inverse operations and how to solve linear equations. So, are there any answers yet? No answers. Okay, I'll give you a bit more time. Okay, -4. So Steven and Reza and Carney all got -4. Kaisi also. Okay, very good. Very fast. Steven. Okay, that was so hard. Okay, after you practice, it'll be easy. Okay, Ethan also said -4. Okay, let's unwrap the parentheses and simplify. Okay, so 5x plus 20 minus 2x equals 3x minus 8 minus 4x. Okay, first step. Okay, and now we just have to combine like terms. 3x plus 20 equals negative x minus 8. Okay, and then let's see. Yeah. Okay, 4x equals negative 28. Okay, x equals negative 7. You all got -4. So please double check my work, see if I'm right. -2x, 3x minus. 8 minus 4x. Next, b. Yes. Yes. And then okay, there doesn't seem to be any problems. So I think you got it wrong. Okay, so did you find a mistake? Okay. Reza, where was your mistake? Okay? Where was your mistake? Okay, probably the unwrapping of the parentheses. Okay, too much numbers. Okay. Too much numbers. Okay, so too much numbers in algebra, usually you can simplify, okay? You can always simplify. And when you see something like this, okay, you might think very complicated, right? And I think I solved that in 30 seconds. I don't know. I just unwrapped the parentheses. And first step is to simplify everything. Okay, unwrap the parentheses, do distributive property. Next step, and this will probably be always be the next step, and it'll be just combining like terms. You see all these x's, you're confused, but there's only two uh, objects really in this. It's just numerals and x. So you can combine them and you get something like this, right? Okay, and then you can just very simple, very simply move all the numerals together and move all the x's together, and you can get the solution. Okay, so I am going to introduce you to inequalities now. Okay, and this might take some explaining, but I'm sure you will understand. So the definition of an inequality compares two values, showing if one is less than, greater than, or simply just not equal to another value. Okay, so an example is 3 is less than x, and it can be 3 is greater than 4. Is that an algebraic inequality? No, this is not an algebraic inequality. That is just merely a true statement. And an algebraic inequality has to have a variable, just like a algebraic equation. Okay, remember. And a lot of you probably don't remember this, but in my first class, in my 5th and 6th grade class, the first class I introduced algebraic equations, and I asked you if this was an algebraic equation. Of course, I said this one was not. Why? Because for the same reason, this one does not have a variable. So if it's an algebraic inequality, it's an algebraic equation, it has to have a variable. Is this an algebraic equation? Yes, that is one. Is this an algebraic inequality? Okay. Yes, because it has an a variable. Okay, and I'll show you what this sign means later. Okay, and you might know already. So, and usually this will be the solution to inequality. An inequality, okay? Same as an algebraic equation, okay? So the x is isolated and numerals on the other side, okay? That is what the solution to an inequality should look like. Now, usually they don't just hand you out the answer, okay? You're gonna have to solve it. Okay, let's take this example. 2x plus 2x equals 2 plus x. Okay, that was our first example of an algebraic equation. So let's turn that into an inequality. And the only difference between an algebraic equation and an inequality, and this is the most major one, and there are some differences when solving them too, but this is the most major one when you just look at them, comparing them. Okay, it's the sign, right? An inequality does not, the two sides are not equal, okay? If you take an algebraic equation, okay, so let's say you were to compare an algebraic equation, okay? X plus 4 and equals to 2x minus 1, okay? So these two sides are equal to each other, okay? If you literally put them on a scale, they will be equal, okay? They'll be balanced. Now, an inequality is that these two sides are not equal, okay? It can be less than, okay? 2x is less than 2 plus x. It could be, let me go over the signs real quick. There are 4 signs in inequalities, okay? You obviously know less than or greater than, but you probably don't know the third and fourth one. Okay, so 2x is less than 2 plus x. Less than is our first sign. Okay, and then we have greater than 2 plus x. Okay, and next we have less than or equal to 2 plus x. Okay, so this means that when we solve it, okay, remember we just move the x to this side, and then x will be less than or equal to 2. Okay? So x will be less than or equal to 2. That's how you solve an inequality. Because it's the same as a linear equation. And what less than and equal to means is that x can either be equal to 2, it could be 2, or anything less than 2. Okay? It could be 2 or anything less than 2. And that's the same with greater than or less or equal to. Okay, so 2x is greater than or equal to 2 plus x. It could be greater than 2 or equal to 2. Okay, does everybody understand the signs? Okay. So Reza, okay, you don't understand. Okay, good. You understand. And Wesley, you also understand. Very good. So, next I'm going to review how to actually solve these inequalities. Okay, how we're actually going to solve these inequalities. Of course, we have to use inverse operations and basic equality. Well, it's not really equality when you're doing inequalities. So remember, what you do to one side, you have to do to the other. Okay? And then remember inverse operations when you're adding or subtracting. So, okay. So let me give you another simple one. Okay, 3x minus 4 is less than or equal to 1. Okay, that is a warm-up question. So can anybody tell me how to solve this one? Okay, this should be very easy. Just solve the same way as you do with an algebraic equation. Okay, please solve. Should be quite easy. Does anybody have an answer yet? Okay, no answers yet. Please solve this one then. Okay. Very good, Stephen. Our first answer, x, is less than or equal to 5/3. Okay? Very good, very good. So, any other answers? Oh, wait. Carney was the first answer. Okay, sorry, Carney. I didn't see your answer just then. Okay, 2 answers. Very good. So, let me walk you through it then. So, remember this is at first just a one-step equation. Just move -4 to the other side. 3x is less than or equal to 5x. Actually, this one is a two-step equation because you have to divide by 3 as well. Okay, so x is less than or equal to 5/3. Okay, very good. And that was a very simple equation. Now, sometimes you come across this, okay? And Carney, you might remember how to solve these ones. -3x is less than or equal to 5. Okay, that was the exact same, the first step of the last problem. Next step would be divide by 3, right? Except this one has a -3, a negative sign. And there's a thing in inequalities, and be sure to remember this, because if you get this wrong, then the whole problem will be wrong. Okay? And this property or rule in inequalities is whenever you divide by a negative, change your sign. Okay? So x is greater than or equal to 5/3. -5/3. Okay? And what I mean by changing my sign is the opposite of the sign you have right now. Okay? So less than turns into greater than. Greater than turns into less than. Okay? Less than or equal to turns into greater or equal to. Greater or equal to turns into less or equal to. Okay? So, but this is only when you divide by a negative number. Okay? So be sure to change your sign when dividing by a negative. This is super important. So if you have your scrap paper out or a notebook, please write this down. This is a very major point in my lecture right now. So if you don't remember to do this, then you might get the whole problem wrong. And it's not might. You will get the whole problem wrong. Okay? So, any questions on this change sign thing? Okay? Carney, do you remember this? Okay, you just remember. Okay, that's good. That's okay. I just reviewed, right? Just reviewed. Okay. So, any questions? Yes or no? Yes or no? Okay, no questions. Then I'll move on. Okay, you went to another algebra class a long time ago. Oh, good for you. And went over this. Okay. So, I'll move on. Okay? So, as you know, solving inequalities is just like just just same as algebraic equations, except when you're solving it. Okay, we have a different sign. And when you divide by a negative, and as I said, this is super important, you have to change your sign. You flip the sign the complete opposite. And this is how you flip your sign, okay? So the complete opposite, less than turns into greater than, greater turns into less than, and you get the idea. Okay? So now let's go over some practice problems. Okay? So the first one is 3x plus 4 is greater than 2 times the quantity of 4x minus 1. So, can anybody please solve this one? I'll give you, since this is your first inequality problem of this lesson, I'll give you about 1 minute to do this one. This is pretty similar to an algebraic equation, so should be quite easy. Okay? Okay. Wesley says x is less than 1.6. Kai-Xi says x is equal, or I think you mean less than 6/5. Okay, I'll go back to the slides. So, any other answers yet? Okay. Yes, less than, please. Remember that when you're doing inequalities, you have to use less than or greater than or the other side. It's not equal to the other side. Both sides are not equal. So please remember, okay? The mistake that people often do. So now that you did it, okay, please remember not to do it again. But it's totally fine. People make those mistakes. Okay, I'll go back to the slides. And if you have any answers, please be confident and put it in the chat box. Okay? And that's been over a minute already. So I'll walk you through it, okay? Carney also says x is less than 6/5. Okay. So Reza asked me how do I solve, so now I am going to solve for you. Okay, so Carney, you'll see later if you do switch it. Okay, so 3x plus 4 is greater than 2 times the quantity of 4x minus 1. As I said earlier, in that very big problem that I give you, all the numbers jumbled up and that sort of thing. Okay? The first step is to unwrap the parentheses if there are any. Okay? So 2 times 4x, 8x minus 2. Okay? And remember, you just, move it, 8x to 3x, 4 to negative 2. Okay? Negative 5x is greater than negative 6. Okay? So now what we need to do is we divide by a negative 5, and x is greater than 6 over 5. Is that correct? And you got you got x is less than 6 over 5, right? And you are correct. So I purposely made this mistake to see if you guys caught this. This is a negative 5, and what I said about negatives, when dividing by a negative, you have to change the sign. And I'm sorry I didn't mention earlier, but when you're multiplying by a negative, you also have to change the sign. Okay, I forgot to mention that. When you're multiplying by a negative, you also have to change your sign. Okay. Usually, I think. Yeah. But usually, I think it's just dividing by a negative. Okay? I think it's just dividing by a negative. But usually, you just divide by a negative. So 5x is greater than negative 6, right? And then you do this, change your sign. That should be your answer. Okay. So, any questions on that practice problem? All of you got it correct, so I assume no questions. Okay, so number 2, we have negative 3x plus 5 is less than or equal to negative 6. Okay. So, are there any questions on the last problem? If you do, I'll go back to it, but for now, let's focus on doing this problem. Okay. Number 2, please do it. I'll give you 1 minute. Okay. And Kai says x is less than or equal to 7. And Wesley says x is more or equal to 7. Okay? One of you might have to check your answer because your answers are the exact opposite. So maybe there is some sign switching. Okay? Please recheck your answer, one of you. And I believe I know who it is. Okay, please check your answer again. Make sure there's no negatives that you're dividing by. And when there are, please change your answer and change the sign. Okay? So, any more answers? Okay, yes. Kaishi, you changed your answers more than or equal to. Very good, very good. Thank you for realizing your mistake. And Carney or anyone else. Okay. Do you have any answers? Okay. Okay. Does anyone have any more answers? Uh, if not, then I will go over the answer. Okay? So, negative 3x plus 5. Okay? Negative 3x plus 5 is less than or equal to negative 16, right? And we see here that 5 and negative 16 are both numerals, so let's combine them. Okay, let's move the 5 over to the right-hand side. So negative 3x should be less than or equal to negative 21. Okay? And then, remember we're dividing by a negative right here. Okay? And what you do when you're dividing by a negative is that we want to flip the sign. So x should be greater than or equal to 7. Okay? So Wesley, I think you're the first one that got that right, and I see you later changed your answer. Very good, very good. Okay. So does everybody understand this problem? Okay? Does everybody understand? Yes, very good, very good. So let's move on. Now we are going to be graphing single variable inequalities. Okay? And I'll explain more on this. Okay? So x equals 2. Okay? This is an algebraic equation. Okay? This is most likely the solution of an algebraic equation. And usually with, algebraic equations, algebraic inequalities, you can graph them. Okay? Remember in my last algebra section called algebraic equations 4, I think, algebraic equations 4, I went over the ways to graph a linear equation, right? Slope-intercept form, point-slope form, and standard form, all that stuff. Okay? But graphing single variable inequalities, I really didn't go over that. But it's quite simple, really. It's just the x-axis, right? It's just the x-axis. Because you only have the one variable x, right? You only have one variable, it's only going to be one line. Okay? This is 0, 1, 2, negative 1, negative 2. What is x? X is 2. X is right here. Done. Right? It's that simple. Okay, we know that x equals 2. We just draw a point on 2. Done. We're done graphing. Okay, now let's compare. What about single variable inequality? Okay, single variable inequalities. Okay. What is this one? Okay, Mike. iPad just shut down. That was bad. Okay. And then inequalities, and please do not and just forget my iPad password. Yeah, just forget it. Just forget. Okay? Forget. Okay, so x is less than or equal to 2, okay? So let's say x is less than or equal to 2. That was a not straight line, so I'll redraw it. There we go. 0, -1, -2, 1, 2. Okay. So what happens when you're we have an inequality? Okay, so let me just graph this. Okay, beforehand. Let's graph it beforehand. Okay. And this should be our graph. Now, why is this our graph? Okay, I give you a little note, okay? So, this depends on the sign, okay? In this graph, we have an arrow and we have this dot over here, this point, okay? And this signifies whether this is less than or greater than, or it is less than and equal to, or greater than or equal to. Okay, so this problem we had less than or equal to. And if we have less than or equal to, we have to draw a closed circle. Okay, you have to draw a closed circle. Now, if this was just less than, we have to draw an open circle, but in this case, it's a closed circle. Now, why do we have the arrow? Okay, this is an inequality. X is less than or equal to 2. Okay, it could be 2. It can be 1 or -1. It can be 3. It can't be 3. Why? Because 3 is greater than 2. It can be anything. It can be 2 because it's equal to 2, or it can be anything less than 2. That calls for infinite possibilities, right? There are infinite decimals between all those numbers. So infinite possibilities. Okay, so this is a wide range. It doesn't just give you a single point like an algebraic equation. X does not just equal 2, okay? It's infinite possibilities, but there's a range, okay? There's a restriction. It has to be equal to 2 or it has to be less than 2. So the arrow can't be pointing this way. Why? Because if the arrow points this way, this is where 3 and 4 and all the numbers bigger than 2 are. So that is why the arrow is pointing to the left-hand side, where the numbers less than 2 are. So that is how you graph a single variable inequality, okay? So does everybody understand this one? Okay. Very good. So does everybody understand, yes or no? Okay, no questions? So I'll move on. Now let's do some practice problems. Okay, we still have 17 more minutes, so this should be enough time. Okay, so please solve and graph this inequality. Okay. Okay, I think Kaixi was the one. Okay. I don't know how you managed it, but you did graph a good line. But the others, I don't think you can do it on a computer. It's kind of hard. So you can just do it on your scrap paper. But do give me the solution, okay? The solution should be x is less than or equal to something, okay? Or greater than or equal to something, Okay, you get the idea. But give me the solution. You don't have to give me the graph. But in Kaixi's case, Kaixi can probably give me the line, but it's not mandatory. Okay, so but please graph this on your own paper. Okay, so now your time starts. You can start figuring this out. I'll give you 1 minute. Okay, so please begin. Put it in the chat box when you're done. Please be confident. Okay. Okay. Hi. She says x is greater than negative 1/2. Okay, very good. And the line 2. Very good, very good. I haven't figured out the problem yet because these are just random problems and I don't know if your answer is correct or not, but once I solve it, you'll know. Okay, and Carney figured out how to do it as well. Okay, very good. Line and Carney's answer is different from Kai's, so we'll find out which of them is correct. So, who is the third person to give me an answer? Okay, Carney, you think you did it backwards. Okay, well, that's not good. Any more answers? If no, then I'll walk you through it. Okay, so solving and graph this inequality. First, do the parentheses as always. 4x plus 4 is greater than 2x plus 3. Okay, move the 4 to this side and move the 2x to the other side. 2x is greater than negative 1. And divide by 2, x is greater than negative 1/2. Okay, now let's graph. We have 0, we have 1/2, we have 1, we have 1 and 1/2, and that. Okay, negative 1/2, negative 1, negative 1 and 1/2. Okay, I'm sure you get the idea. And we have our negative 1/2 right here. Okay, open circle. Okay, remember. Okay, I gave you a note. If it is less than or greater than, create an open circle. Okay, so remember we have our open circle now, and our arrow should go to the right-hand side. Okay? So, because it has to be greater than -1 half, right? And on a number line, the right side will be greater than the left side, okay? And here's a little trick to help you out. Okay, so it's if your x is on the left side and your numeral is on the right-hand side, it's perfect, okay? And you see this sign, right? You see this sign, and the little trick might this will help you know which way the arrow goes. You see this line resembles an arrow, right? And this sign, the way it points, that is where the 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 arrow will point. Okay? So let's look back. In this problem, this little arrow was pointing to the left, right? And that's how it turned out. Okay? So that's a little trick that helps you. Okay? So now we're going to be graphing two variable inequalities. Okay? And two variable inequalities, it's very similar to algebraic equations. To graph two variable inequalities, you need to have two variables, x and y, and you have to put them in y-intercept form. And y-intercept form is y equals mx plus b. Okay? So let's say x minus 1. That's y equals x minus 1. That is our problem. Okay? So remember, now we're on a coordinate graph. Okay? And when we were graphing algebraic equations in my last few classes, it went like this, right? Just lines, right? Lines on this coordinate graph. But remember how I said inequalities, right? They are not just one solution, not just one solution. And same with the single variable inequalities, right? They were not just one solution. There are infinite possibilities, okay? So what we need to do here is we have to shade it, okay? Once we have this boundary, everything below it will be possibilities, okay? If there's a different sign, everything above it will be possibilities, okay? Let's say we have a greater sign, everything above it, okay? So less than or equal to signs, okay? And less than signs, okay? Everything on the bottom of the line, okay? Thing on the bottom should be a possibility. For greater and greater than or less than, greater than and equal to signs, okay? Greater than signs, everything on the top is a possibility. So remember, this is because this is an inequality. There are many possibilities, many possibilities. Okay, and I give you a little note here, as with the single variable inequalities. Okay, the sign, if the sign is less than or greater than, okay, we have a graph this dotted line, okay, and a dotted line. Okay, let me erase this line. A dotted line is like this, okay. A dotted or dashed line, okay? Dashed line fits better, okay? A dashed line. Okay, if the sign is less than and equal to or greater than and equal to, graph a solid line like I just did, okay? Like I just did my first line, okay? That was a solid line, okay? So let's try doing some problems now, okay? And we're almost out of time, so I actually have two problems ready for you, but let's just solve this first one, okay? After that, you will be free to go. So, everybody, let's solve this first problem, okay? So, let me walk you through this one, okay? I will save some time. Y is greater than or equal to 2x minus 1, okay? If it has an equal to, and if it's greater than and equal to or less than and equal to, it's going to be a solid line, okay? Next, this one is all this one is already in slope-intercept form. Okay, I put it into slope-intercept form for you. So let's draw our coordinate graph. It's going to be a solid line. Okay, so remember, this is the y-intercept. -1 is the y-intercept. Okay, this is -1. And our slope is right here, 2/1. Okay, vertical change over horizontal change. Okay, 1, 2, right there. You can keep going. 1, 2. Okay, and then to the right by 1, right here. You can do -2 over -1. Go down by 2. 1, 2. To the right by 1, right there. Okay, that's our line. Now this is greater than, okay? Greater than. So this should be shaded. Okay, this should be shaded on the top. Okay? So, thank you for listening, everybody. Okay, thank you for listening, everyone. You all did great today. And please don't forget to subscribe, drop a like, and turn on notifications. Okay, thank you for listening.